Hello everyone, this is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today in this session we will be learning about the few terminologies used in big data environment. Welcome to the session. So the main objective of this session would be to compare various terminologies used in big data environment. After the end of this session, we will be able to analyze the terminologies used in big data environment and to compare the terminologies that are being used in big data environment. So these are some of the terminologies used in big data environment. They are in-memory analytics, in-database processing, massively parallel processing, parallel system, distributed system, share nothing architecture. So these are some of the terminologies used in the big data environment. Let us see one by one. So the first one would be in-memory analytics. So what is meant by in-memory analytics? So in the history, whenever we have to access a data, we access the data from non-volatile storage such as hard disk, which is relatively a slow process. So data access from non-volatile storage such as hard disk is a slow process. One way to combat this challenge is to pre-process and store data in the form of cubes, aggregates, tables, query sets, etc. So that CPU has to fetch a very small subset of records. But this pre-processing requires thinking in advance. So to eradicate this problem, it has been addressed using in-memory analytics. Here all the relevant data is stored in RAM. So using in-memory analytics, there are several advantages. So the first one would be faster access, rapid deployment, and we will be having a better insight and minimal IT infrastructure involvement. So this is how the traditional computing and in-memory analytics is used. So the next terminology used in big data environment is in-database processing. So in database processing, we also call in-data processing as in-database analytics. In database analytics, it works by fusing data warehouses with analytical systems. Typically, we'll take the data from various enterprise OLTP online transaction processing system after cleaning up. So deduplication, scrubbing, etc. will be removed through the process of ETL. Then it is stored in the enterprise data warehouse or data marts. Within in-database processing, the database program itself can run the computation, eliminating the need for expert and thereby saving on time. So the next terminology used here is SMP, which is symmetric multiprocessor system. In symmetric multiprocessor system, there is a single common memory that is being shared by two or more identical processes. The processors will be having a full access to all the input-output devices, and all these are controlled by a single operating system instance. So SMPs, as we say, they are tightly coupled multiprocessor systems. Each processor has its own high-speed memory called cache memory and are connected using a system bus. So the next terminology used in big data environment is massively parallel processing systems. So in short, we call them as MPP architecture. So MPP architecture will be having nodes with each having its own processor, memory and IO subsystem. It will also have an independent OS which runs on each node. So as we say MPP, it refers to the coordinated processing of programs by a number of processes working in parallel. So these processes each will be having its own dedicated operating system and its memory. They work on different parts of the same program. The MPP processes communicate using some sort of messaging. They communicate using messaging interfaces. So the next one we will be seeing about the parallel and distributed system. So parallel database system, which is a tightly coupled system. The processes cooperate while query processing. The user is unaware of the parallelism. In distributed database system, they are also known as loosely coupled and are composed by individual machines. Each of these machines can run their individual application and serve their own respective uses. The data is usually distributed across several machines. The last terminology used in big data environment is shared memory architecture, or we'll say shared architecture. These will be classified as shared memory architecture, shared disk architecture, and shared nothing architecture. So the first one, shared memory architecture. Here memory would be shared across all the processes. In shared disk architecture, only the disk would be shared among multiple processes. The final classification here in shared architecture would be shared nothing architecture. In shared nothing architecture, neither memory nor the disk is shared among multiple processes. So the main advantage of this shared nothing architecture would be fault isolation and scalability. So what is fault isolation? Fault isolation is nothing but it provides the benefiting of isolating the system from the fault. A fault is in a single node is contained and it is also confined. So the next one is the scalability. So the scalability refers to the disk, whenever it is a shared resource, different nodes will have to take turns to access the critical data. So distributed shared system as thus comprising on scalability. So the three most common type of architecture for multiprocessor high transaction rate system is shared memory. So here a common central memory is shared by multiple processes. Shared disk, multiple processes share a common collection of disk while having their own private memory. Shared nothing if neither memory nor disk is shared among multiple processes. So this is the shared nothing architecture. So first one is shared memory. Second diagram shows the shared disk architecture, and the final one is shared nothing architecture. So thank you.